All right, let's begin with our exploratory challenge here. A triangle XYZ exists with side lengths of the segments below, okay? And what I did realize, I just pulled one of your packets out, an extra packet that I give to you guys, and yeah, those measurements in your packet are pretty accurate, or are quite accurate. I was looking at my packet's very different. Everything is kind of shrunken down. So, anywho, yeah. So you have your the lengths of the segments below. These are all pretty accurate. I can actually measure this one. This one is 3 centimeters. This one is 7 centimeters, and then 9 centimeters here. Okay, in case you want to know. Anyway, yeah. So draw triangle x prime, y prime, z prime with the same side lengths as triangle XYZ. Okay, so use your compass to determine the sides of triangle x prime, y prime, z prime. Use your ruler to measure the side lengths. Leave all construction marks as evidence of your work, and label all side and angle measurements. Okay, so as you can see, you're going to use your compass, and your compass, of course, means you're going to create circles. Okay, so leave all the circles. Don't erase anything. Well, you're not going to show it to me anyway. You can do whatever you want, I guess. But it's really nice for yourself. I don't know. The circles, creating triangles with circles is just, I think, such a freeing, empowering thing for you to be able to do. And I hope you feel the same. Anyway, so we're going to answer some questions. Under what conditions is triangle x prime, y prime, z prime drawn? Compare the triangles to your peers. Now, you're not going to, okay, so you could skip that. Are the triangles, we'll talk about the triangles if they would be identical or could they be identical, blah, blah, blah. Okay, but firstly and foremostly, would you go ahead and draw that triangle x prime, y prime, z prime with these side lengths. Okay. Okay, so as I decided to draw my triangles, x here, x, y, z, okay, whatever it looks like. I'm doing it that way, so therefore I'm starting with my x point, my x vertex right here. Okay, that's my x. And what I've done is I know that I measured in my, in your packet there, that segment xy is 3 centimeters. Okay, so I dial into my 3 centimeters. See my notch right there. All right, now I'm going to go ahead and I'm going to make my my circle with a radius of 3 centimeters. Okay, and let's go ahead and take a look at that. Okay, so there it is. So all of these here, all of these are lines of radius, and they are all going to be equal to 3 centimeters. Okay. All right, so that's that. Now I also know that my another segment XZ, okay, because I want Y to be up here somewhere. Okay, XZ, here's Z. That is 9 centimeters. Okay, so I can just go ahead and draw that line. And it doesn't matter if I draw it like that, or I draw it like that, or over here. It doesn't matter. These are circles we're working with here, which is really just awesomeness, man. I'm telling you. It doesn't matter, because it's all going to write itself that you had circles. I've just been trying to draw mine pretty straight across, but it really does not matter. Okay, the straightness or the evenness of that line means nothing. Okay. All right, so next, just erase all this because I think I actually add this in. Okay, so what I did is I have point Z here. Okay, I've drawn my my 9 centimeter line from X, and Z is right there. And again, I know that that line is 7 centimeters long. Okay, that's going to go from Z to Y, or YZ. Okay, that's the other one. I know that's going to be 7 centimeters, so I'm going to draw my circle with a radius of 7 centimeters. And that's what this looks like, right? That's what it looks like right there. Get all the messy stuff out of there. Okay? And there it is. So I've drawn my two circles. Okay, this is my of course my radius here. These are all 9 because I know I want that line that's going to go to y to equal, not, well actually you know where that's actually going to go because we can see it right here, and I actually have drawn it, but I just want to show you right now, which is so great. All we have to do is line up my ruler so where these circles intersect, and again I could use that one or I could use that one there. Okay, so actually let me just go ahead and show you. I could draw it here just with a straight edge with a ruler. Okay, I could draw that. Okay, and that would be correct. Okay, but and then this would, of course, y would be down here, right? The y is actually right going to be there. But what I did is I drew it the other way, just being a right side up kind of guy. I drew that. All right, and there you go. What's so nice is you do not need to measure that. You don't need to measure that, okay, because you have done all that work already right here and right there, okay? All right, well, that's super. Again, let's go ahead and let's go answer some of these questions now. All right, so again, we don't have any peers necessarily to check with, okay? Can't check peers. But the fact is, would the triangles have been identical? Would they have been? And that is my question to you. Okay, and the truth is, yes, they all would have been identical if we had 3 sides, the measurements of all 3 sides of a triangle given to us. Everyone doing that, everyone creating a triangle with 3 sides of those different measurements would indeed have created a triangle that was identical to yours, okay? Which is really amazing, I think. Really, really amazing. So we know what conditions determined a unique triangle and all 3 sides. If we know all 3 sides, we're there. Okay, so triangle ABC is located below. There it is right there. Okay, ABC. What they're saying is copy the sides of the triangle to create triangle A prime, B prime, C prime. Use your compass to determine the sides of triangle A prime, B prime, C prime. Use your ruler to measure the side lengths. Leave all construction marks as evidence of your work, and label all side and angle measurements. Okay. The question will be, under what condition is triangle A prime, B prime, C prime drawn? And then compare the triangle to your peers, which we won't be able to. Are they identical? Blah, blah, blah. Well, we can really cut to the chase here, because if you went ahead and copied the sides of this triangle ABC, and again, you know how to do it by now, okay? All you would be doing actually is you'd be measuring. You'd have to measure this side, this side, and this side, and you would go ahead and maybe you could do this BC first. We could draw it this way, BC, and then of course we have B over here. Well, then of course, but I'm just saying we would in this case. And then we want to know we know the length of this because we've measured it here. And then we just draw we draw our circle from there, and then we have C over here, and we draw our circle from whatever length that is out, this length right here, and get another circle, wah, wah, and then you know what I mean, boom, boom. Okay. Now, under those circumstances, yes, indeed. And again, I'm not doing it because if you want to do this, please go ahead and practice, 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 because like I said, it is a lot of fun. I am just trying to get these done for you guys so you can have all of this at your disposal at any time, okay, quickly. And I'm blah, blah, blah. I've been doing this too long today. Anyway, yeah, so there you go. You have that. We're not going to do it because, cut to the chase here, The truth is, if you have the three sides, just like I said before, and that's the condition that A prime, B prime, C prime was drawn under, you will always create identical triangles. End of story. Okay, so this number 3 here is a little bit different. It says a triangle DEF has an angle of 40 degrees adjacent to side lengths of 4 centimeters and 7 centimeters. Okay, so construct construct triangle D prime E prime F prime with side lengths D prime E prime is 4 centimeters and D prime F prime is 7 centimeters, and the included angle, angle D, equals 40 degrees. So now you're given two sides, you see here, two sides, and an included angle, okay? Leave all your construction marks as evidence, blah, 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 under which conditions, and then we will just talk about that. So go ahead and do that and see what you come up with. Again, use whatever tools you need. Okay, so my first step was to use my my protractor. I drew a line first, my bottom line, which is going to be, or my bottom segment, which is going to be actually a DF. A DF first, and then I drew. I used my protractor to measure 40 degrees, and then draw my segment DE. Okay, and that looks like this. Nothing is drawn actually to scale yet. Okay, this right here, actually, that reference point there was actually my little dot that I put down to show where 40 degrees was on the protractor. Okay, that's what that is. It's not actually point E. All right. So next, well, of course, I know that's 40 degrees right there because I measured that. Next, I went ahead and found my point E, okay, because I know that DE is 4 centimeters, and I put E up there. You didn't have to. You could have put E down or could have put E on the bottom. Doesn't really matter, okay. And then I went ahead and found that 7 centimeter point because I know that DF is 7 centimeters. Now, which is wonderful, all I need to do is connect those two dots and 2 points, and I have my triangle drawn. Okay. Now, if you want to, you can go ahead and, if you wanted to, you can go ahead and measure this side, and if you did, you would have gotten approximately about 4.7 centimeters. Okay, 4.7 centimeters. This angle here was about 33 degrees and about 107 degrees here. Okay, and that would be really neat if you did have all of those just about the same. Now, again, the question, of course, the big question is, we can't compare it to peers, but with these conditions, would this determine a unique triangle? And the truth is, yes, by having the two sides and an included angle, okay, and that means it's included, it's adjacent to the two sides, okay, it's there, it's included with those two sides. That is enough to create identical triangles. Okay, so here we are on number 4. We got triangle XYZ has side lengths. So giving you the side lengths here. XY is 2.5 centimeters. XZ is 4. And you have angle X, which is 120 degrees. Okay, I can't highlight that because of the way my interface is here. So anyway, yeah. So we have those three. We've been given two sides. Now I ask you one thing to probably consider first. If you think about it, here we have X. We have X and then we could have maybe y here, and z, x, y, z. Now if we know x, y, and we know x, z, and we also know the angle x right here, my question to you would be, is that considered an included angle? And the truth is, it is, okay? It is included. So we could go all through all the rigmarole, and if you want to, please help yourself, okay? Go ahead and use your ruler to measure the side lengths, leave all the construction marks, and blah, blah, blah. But having two side lengths and an included angle, okay, because it is right there, it is between those two sides, you will indeed create identical triangles. Okay, the conditions did determine a unique triangle, a triangle like no other. Because look at that, you have that already. All you need to do is all you're gonna have to do is just draw a line. Okay, there's not going to be much to it, and that line will always be the same length. And the truth is, that is. So if I could just put all these in here, as you can see, you don't need to do this. That's what these all turn out to be. This is 5.7 centimeters, and then we had 37 and 23. Okay, but it might be fun if you want to go ahead and try this out and see if you do get. Just leave that here. You can see the answers. Do all the put all the parameters or the conditions in place, and go ahead and see if you actually get these angle measurements, for example, which would be pretty exciting. You should, okay, in a perfect world. All right. Anyway, that is that. Okay, that is actually what we were getting to. Again, you can see we had two examples of three sides given, and we always came up with identical triangles. Then we were given two examples of two sides and an included angle, and it was the same. You will be constructing identical triangles. Okay, so those conditions, both scenarios of conditions there, were enough to be given to create identical triangles. So again, in closing, by drawing triangles under the three sides condition and the two sides and an included angle condition, we see that there is only one way to draw triangles under each of these conditions, okay, which determines a unique triangle. Every triangle drawn with knowing the same three side lengths or knowing two side lengths and an included angle, every triangle drawn will be unique and it will be identical. Okay, it's one specific triangle that's being drawn, and you can draw them over and over and over again, and if you have those conditions met, they will be identical. Okay. Diagonal, we use the word, I didn't actually use the word diagonal, but in the problem sets, it looks like the term diagonal is going to be used for several of those questions. Okay, so I just want you to expect this, and you can, and the definition, of course, as you know, we can look at it right here. We'll just go ahead and look at this lesson summary here to show you some diagonals. Okay, so the following conditions determine a unique triangle: three sides, which I just mentioned, and then two sides and an included angle. All right. So here in quadrilateral ABCD, see ABCD, the segments AC and BD are called the diagonals of the quadrilateral. Okay, so that is something you're going to have to look for in your problem sets. Just remember, you can refer back here. These are called the diagonals. Okay, and they there'll be another name for those in the future. But yeah, those are the diagonals, also known as the hypotenuse. But anyway, you will see that, hear that some other day. Okay, go ahead. This was a really chintzy little 20-minute video. Hopefully it helped you see the conditions under which identical triangles can be, well, at least some of the conditions under which identical triangles can be created.